Hi friends, in this video we are going to find out the taperness of this specimen by using the sine bar. So we want to find out the taperness of this specimen by using this sine bar. We will see in this video. So before going to find out this taperness, we need to just know about the sine bar and its working equation, working formula, and the description parts of this sine bar also we need to learn. First, if we observe here, this is the sine bar setup, and these two members are called as the rollers. These two are the rollers of the sine bar. On these two rollers only the entire the body of the sine bar is mounted. So these are the two rollers. So on these two rollers only the entire weight of the sine bar is mounted. So the distance between these two rollers is nearly 200 mm. So if you observe here, the distance between the two rollers of this sine bar is 200 mm, and this is the constant. So every sine bar is having the same 200 mm, it is not applicable. So based on the length, based on the distance between the rollers, the sine bars are classified. So some of the sine bars may have 600 mm as the length between the two rollers, and some of the sine bars may have the 400 mm as the length. So like that. So in this video we are just using the 200 mm as the length in between the two rollers of the sine bar. So and this is the upper surface of the sine bar, and this is the lower surface of the sine bar, and these are the stress relieving holes. So as we know that every body is having its own weight, so to withstand that own weight, these stress relieving holes are provided for this sine bar. Only stress relieving purpose only these holes are prepared for this sine bar. Okay, so with the application of these gauge blocks, the entire sine bar will work. Okay, so all these are the gauge blocks and slip gauges. So these upper bodies, big bodies are called as the gauge blocks, and these small specimens, the small bars are called as the slip gauges. These are the slip gauges, and these are the gauge blocks. So we have to set these gauge blocks and slip gauges as a height. Based on that height and the length between the two rollers of the sine bar, the sine bar will works. So basically this sine bar will works on the equation, that is sin theta is equal to h by L. So based on this formula, that is sin theta is equal to h by L. So here theta is equal to taperness of the given specimen. So this is the specimen, and this is the taperness. This taperness is we are going to find out by using this sine bar. Okay, so this is the taperness of the specimen, and h is the heights of the gauge blocks. So these are the gauge blocks and slip gauges. So next, L is the length in between the two rollers of the sine bar. So this is the this is the one roller, and this is the another roller. So the distance between these two rollers is 200 mm, that is constant. that is constant. Okay, now we can apply this formula and get the theta value. Let us see how we are going to get the theta value by arranging the gauge blocks as a height, and specimen should be placed in between the uh, heights of the gauge blocks, and as well as the specimen needs to be parallel to the lower surface of the sine bar. Let us set the position right now. See, here I am so here I have set this specimen in between the two rollers of the sine bar by taking the one of the gauge block as a height and taking the L as 200 mm and keep this specimen which is parallel to the bottom surface of the sine bar. So this taperness of the specimen should be parallel to the bottom surface of the sine bar. So let us see. Yes. Okay, now we can take this as the height. Okay, so this gauge block I have taken from the gauge block setup, that is 80. So here I have taken the 80 mm height of gauge block as taken as the height here. So let us take H is equal to 80 mm. So if you observe here, this 80 mm as the height here. This is the 80. Okay, now you can apply these values in the formula, required formula, then we will get the theta value. Okay, so this is the formula we are having. Here I am going to calculate 2 10 ja, 2 10 ja, 2 4 ja, next 2 2 ja, 2 5 ja. Okay, so sine inverse of 2 by 5. Now we can check this value with the help of Casio.